welcome to this track on power and renewable energy electronics. As all of us know, gone are the days when power was only something to do with a generator and a genset, and having some water power. Today, power industry also uses a lot of electronics, right from smart meters to managing the distribution of power. There is a lot of electronics involved in that area. Typically, you have power semiconductors and you have very high-end power devices. So today we have on our panel Mr. A.N. Srivastava. He is Director, National Solar Mission, Ministry of New and Renewable Energy, Government of India. Mr. Mukundan, Narasimhan. He is AGM, Product Management and Exports at Tata Power Solar. And Mr. Ramesh, Narayanan, CEO of BSE Yamuna. So may I request Mr. Ramesh Narayanan to start off the proceedings of this panel as a key consumer of power and distributor of power to people like you and me. Okay. So over to you, Mr. Narayanan.
Thank you. Can I take the... He just asked me to join in the session here. I was wondering what the distribution guy is going to speak about a hardcore electronics. So I decided to consult my daughter, who is doing electronic and communication. I said, let me get some idea about the linkage between electronics and electric. She thought for a while, and then she said, I said, how they are related. So she says, the only difference is, for every electric to be on, if it's switched on, then it becomes electronic. The difference is just one O-N there. Otherwise, electric and electronic, they are very much comparable. So if you switch on the electric, then it becomes electronic, and they are equally dependent. So you can't have electric without electronic, and electronic without electric. So very interesting analogy, I thought. Then I walked up to my colleague. I said, let's make a interesting presentation, and we should make a very responsible presentation. He told me, look, I've made a presentation. I went through the presentation. And I said, you think we'll be making a responsible statement here? He says, I know you're going to, it's going to be a very responsible presentation, all right. But, we are responsible for what we say, but we are not responsible for what you understand. That's very important that we are in different leagues. Jokes apart, I'll come to the business directly. As Giridhar started off, there's a lot of important role an electronic sector plays for the power sector. So we have the generation, transmission and distribution side. So in all the three sectors, today you cannot think of a power sector without electronic playing a significant role. Whatever we do, it's all linked up to electronics and IT. If you look at just to give you a little background on the sector, when we started off in 1991 with the reform, the objective was we have to accelerate the development of the sector, and it worked. So we had about 67,000 megawatt, and the reform process helped in adding 210% capacity in just about 20 years. So what we added from 1905 to 1991, that was about 67,000 megawatt. And from 1991 to 1992 to 2012, now we have an installed capacity of 206,000 megawatt. That's about 210% growth. So you opened up the sector. So you made some rules easy. So a lot of investment did happen, and the technology did change on the generation side. But then the power which we handle at the grid level is just about 1,35,000 megawatt. So you have an installed capacity of 2,06,000 megawatt, but the power which you actually deliver to your consumer is close to about 1,35,000 megawatt. So there is a mismatch in the balanced development there. And if you look at the technology, by and large, on the distribution side, you have, a very archaic kind of a technology, but thanks to the BDRP and other initiative with a $10 million investment getting in there. So some IT-enabled modern systems are getting in place. And we are trying to, you can't overnight replace all your existing investments. So at least the roadmap we are trying to define. What should be the future distribution sector should look alike? And there's a lot of development on the generation side. So we are trying to get a matching development done on the distribution side as well. So that matching power demand, matching growth, that's the biggest issue. Because unless you have the wires and the transmission systems in place, your capacity which you have created on the generation side will probably get bottled up and will not reach that end user. We have 2,06,000 megawatt, but you still have lots of villages, lots of cities, lot of towns, who do not get 24/7 power. So you can hardly count those number of cities. That's because the investments are not happening, proportionately on the transmissions and the distribution side. So you've got to have a kind of a right mix between the investment getting into the distribution side vis-a-vis the generation side. We are talking about a whole lot of generation mix. And with that, we have a lot of complexity which gets into the sector. We are talking of renewables coming in a big way. We are talking about how do we have a system. Typically if you look at the distribution side, we are on a reactive mode. We wait for a outage to happen, then we get a call, then we get into action, then we try to fix that problem. So there's a lot of business interruption. We want to have a paradigm shift here. We want to change the concept where the utility should know in advance, of an imminent problem and fix it before the outage happens. It helps in reducing redundancy. It helps. Now you look at distribution side. On the distribution side, the quality of service depends on the last guy providing that service close to your end user. So, and it is spread across the entire license area, geographical area. So the variability of service is essentially because, the kind of checks and balances or, bringing them all at par is very difficult. Everybody is on his own learning curve. So how do we bring him all into one place? So there is a need for a simulator. On generation side you have simulators. On transmission side there are few simulators in the world, but we don't see any simulator on the distribution side. So you got to have a simulator, and you can capture all those experiences onto the simulators, use that on the research and development, and then bring every consumer at par with that. So these are some of the gaps. So what we find is the sector is pretty much obsolete, if I can use that word, and it requires to be infused a fresh thought, some out-of-the-box approaches. Some of us have started it, and if you look at, I just already mentioned this to you, that accelerated growth in the generation side, and there is a lot of incentive which worked on the generation side. There has to be a matching kind of a thing on the distribution side. Maybe the second phase of reform is to be focused on the distribution side, so that you have a matching infrastructure to that of the generation, so that the real benefits of development percolates to that end user. So, and in the distribution side, you got to think of, doing things differently. Just to give an example, the Rural Electrification Department was trying to electrify every single village in the country. And when you look at any of their tenders, they would ask for a transformer, some LV main, some RMU or some kind of a breaker, and then they would do all these jigsaw puzzle on the field. Then they will worry about how do we communicate to a load dispatch center or whatever. So why all these can't be assembled and put together in a controlled condition in a factory with all communication devices together, and then put it up at that location. You don't go and buy a car in parts. You don't order for an engine, for the wheel or the body or whatever, and assemble them together. When you drive it out of the showroom, you expect that to perform right away. So a lot of our projects languish because these kind of the way in which we approach executing these projects. So these are issues which have we need to address. I mentioned about the kind of gap which we have created. We have installed 2,10,000 megawatt as on date, but the grid demand we supply is 1,35,000. So it doesn't mean that we have a spinning reserves of about 75,000 megawatt. A country like this, if we have that capacity, we're going to certainly deliver that energy everywhere. It's essentially because you don't have those wires, you don't have those investment on the distribution side to matching up with the generation, and the power doesn't reach. There is a Gurgaon in our neighborhood, there is a Greater Noida in our neighborhood. They ask you for power, and we debate everywhere there is open access is not successful. Essentially because you don't have wires to take the power there. There are consumers who have set up big load centers, and the back-end infrastructure in terms of substations, grid, they're all not there, they're not adequate. So if I have to supply to a person X, then I have to deny another person Y. So unless infrastructure come up, unless they are seen in totality, unless we stop doing this jigsaw puzzle on the field, this problem is going to persist. Unless we're going to match investment similar to what has happened on the generation side, this sector is going to languish. So there is a need. Then there's another problem. If you look at this sector, typically, right from the day when this power was introduced, why blame only our local conditions here? You look globally, you will find that the sector is essentially segmented into 4 consumer class: domestic, industrial, commercial, and agricultural consumers. Now, if you look at each of these consumers, are they consuming power differently? Whether the domestic consumer is consuming electricity in any different way than a commercial consumer, and how is an industrial consumer different than an agricultural consumer, then why do we segment like this? So we basically seem to be barking different trees, wrong trees. See, if you look at each of these consumer segments and find out how do they use electricity, you find that we use it essentially for 4 applications. We use it for lighting, we use it for heating or cooling, we use it for traction or drives, we use it for pumping. Now, if the usages are defined correctly, then a lot of your problems can be very well solved. Now, if you look at, out of this 1,35,000 megawatt, what is that maximum demand each of this usage constitute? I was very surprised when my guys worked out and showed to me that actually the pumping load constitute almost 50% of your load. Now, if you look at whether the conventional electricity which we use for the pumping load is relevant, or is there a better way to supply that power there? So first you establish long LT lines, then you say, look, they are not metered, then they contribute to the power quality, then there are some inherent technical issues with this pumping arrangement, then you try to solve the problem. So you create a problem and you solve the problem. Now, can we have a decentralized power supply to them? Is it easier to store water than storing electricity. Maybe you can use the solar energy, pump all that water, and then directly store it on a tank and use it as and when you require. Or do you want to leave that farmer at the mercy of the discom so that they give it to him as and when they want, because he's not a remunerative consumer? So there are issues. In a typical electronic sector, the IT sector, it has distinguished itself by asking such questions, by tailoring a solution which the sector needs. But in a power sector, we have stopped asking questions. We have just adopted whatever was being practiced right on the day when this sector was put on the road. That's the biggest pain of the sector. The sector is too mature for anybody's comfort. There is hardly any research and development going on there. There is hardly any collaboration between an institute and a utility happening. There is, those allied sectors are not stepping in. We are not, engaging them in coming up with some solutions which actually address problems. So these are the kind of issues. And if you look at, we have this renewable energy, solar energy. We use those lanterns and lights and whatnot. So those lights, when do you use it? When there is no sunlight. So first you try to capture that energy, store that energy in a battery, and then try to use it at a time, when the sun is not there. And if you do look at the characteristics of this load is very useful for your base load stations. If you have a nuclear station, you want to run that station when that load is not there. So he's actually aiding that kind of a base load station, because the decommissioning or backing down of that station is more expensive than operating that station. So actually you are defeating your own objective when you say I am going for a solar lantern or a solar light or whatever. That load is actually helping the grid. So if you have the pump instead, which adds to your peak load, to be powered by solar, and he stores just the water, you don't have to segregate those long feeders. So a lot of thought needs to be, we seem to be having a fixed mindset where we say, look, our effort is convert all the renewables into electricity and then use it on our traditional equipments. We've got to structure it a little differently. If that energy has some characteristics, if it has got some, typical quality, you've got to see how that quality can be adapted to your use. Instead of being rigid on your use and adapt that technology to my end usage. So that seems to be the, bigger issue here. And so what we did, as I just mentioned to you, pumping load is the biggest load, and you pump everywhere. Farmers, they pump. You have petrol pumps, you pump sewage, you pump water, you pump whatever you can think of. Every household is engaged in some kind of a pumping load. And which is the most suited form of energy to be used for this pumping load is the question to be asked, is the question to be engaged in. Lighting load, a different load. So this load, ballpark, it's almost about 18%. And when I think about a situation when you don't have any lighting load, and that load is knocked off from your system, what happens to all those big nuclear plants? What do they do between 7 in the evening and 9 in the evening? So when the commercials are all switching off and you have load centers, will they be in a position to back down their units? These are the kind of questions to be asked. So what is that form of energy which is most ideally suited for this kind of an end use? So right from the segmentation, right from the right kind of mix of energy, these kind of thoughts are very, very crucial. Look at drives and tractions. You need huge bulk load. You have the metro, you have big industries running, all traction. they contribute to a whole lot of quality issues. So if you have a metro on a single traction, it's actually contributing to harmonics. So you require filters, you require this. So there are some issues. So what is the kind of energy which is ideally suited for this kind of a load? Heating, cooling, again, renewable could be an excellent source. So that kind of a right mix for that right, application is very important. So our objective is to engage in this kind of a, exercise. So for this purpose, we decided to collaborate with IIT Delhi. So we have this first Industry Institute initiative, and we identified 4 basic, projects to begin with. And we defined that, look, we are going to have a time frame within which we will deliver some kind of a solution in this sector. So we developed what is called a renewable energy assisted pump. This is REAP. And this pump, it's already commercialized, patented. We have the MNRE accreditation for it, and it's selling like hotcakes. And this pump is installed in various schools and colleges. This has improved the sanitation and drinking water purpose. It's off-grid. It doesn't waste water. It's DC driven. And when our guys conceived this, developed, there's a lot of controller, everything, electronics in it. When they developed it, they said, you think from the consumer point of view. What does the consumer want? He wants guaranteed water. So you talk to any pump supplier, he talks about head, he talks about discharge, he talks about every other thing except telling you how much water will this pump give him at his desired location. So that's what the IIT guys said. Make it customer centric, customer focused. The customer first question asked was, how much is the water this pump is going to give? So they guarantee water, not anything else. 25,000 liters a day. And it can reach to a height of 90 meters. That's a 20-story building. 25,000 liters a day on an average day. So, and by and large, in a year of 365 days, 330 days, it's an average day. The water gets stored on a 5,000 liter tank, and the tank can fill up 5 times. And if the water, as soon as the water comes down to a certain level, it works, it pumps up again. So it's not wasting of the water, it's not indiscriminately pumping and pushing your water table down. It's revolutionized. We talked to those school teachers. They said their attendance have gone up, especially some of the girls' school where we have installed it in Delhi. We didn't want to install it first on the rural side, because normally people say all these kind of guinea pig technology you tried only on the rural side. We said first we want to try it in Delhi. We're going to make it successful here and then take it to the rural side. So we did it here. And the attendance have improved. They said we used to carry water to the school. Now they say we carry water bottle to the school and take the water back to the school to home. That's what the shift has happened. The attendance have improved. So we got it, we give all the credit rating, everything has been done. MNRE is kind enough to give us a subsidy on these pumps, and it's working well. So we have put in 4 different pumps. As I mentioned to you, we are guaranteeing on the discharge of this pump. So you see, the smallest version gives you anything between about 25,000 liters. The other one is about 35, and the largest one can give you up to 60 to 70,000 liters. So this is the first product we developed. The second product, as I just mentioned to you, if you typically look at any utility in the country, how do they operate? You don't have a power, you call them up, then they react. We said, we're going to change this approach. And the utility got to know it before the consumer comes to to know of it. Why should there be a business interruption? You got to supply 24/7. And we have learned it the hard way, I tell you. The moment our reliability has gone up, even if the power is not there for a minute, we are hauled up. So we are paying the penalty for our efficiency. But then we have got to live up. You have created your benchmark, you have got to raise it still higher. So we developed this product, what we call our smart substation. Again, IIT helped us. We have developed our own a smart device with a lot of probes. We wrote the firmware, we wrote the applications. Under the guidance of the professors, we patented it as MIDAS, Modular Integrated Distribution Automation System. All your SCADA work right up to the medium voltage level, 33, 66 kV level. But the population is there on the HT and LT level. I have, for distributing, say, something like 1,500 megawatt in my license area of 200 square kilometers of 1.2 million customers. I have 50 medium voltage grids, 52. And I have 2,250 11 kV substations. Typically, if one substation goes, develops any outage, there are 500 consumers affected. But 500 is a number. So we said, and we were building up a lot of redundancy, creating a ring, and then we were into a big mess. This has probes in the transformer, on the RMU. It has a sensor to find out if there are any intruders. It has a fire sensor. It can read your meters on those distribution transformers. It has a whole lot of input-output devices. It tracks it 24/7 and constantly uploads it on your server. And then if the parameter goes beyond some prefixed numbers, it sends an SMS to the lineman. And if he's got an Android phone, it tells him the shortest route to reach there, because it gets its location. It sends the information through the SAP to the module, to the storekeeper, saying, look, keep this material ready. And when the guy lands up there, he doesn't have to raise an invoice or a store issue voucher. He gets the material because it's all already logged in. He draws the material, he goes there and fixes the problem before the catastrophe has happened. So the consumer has not even come to know of a kind of an imminent outage situation. The problem is not just that. It goes one step further. If this guy doesn't act on that call, it escalates. It helps us, our engineering department, to find out what is the loading of that transformer. It has moved to our new way of maintenance. Earlier it used to be outage or breakdown based maintenance, where you send your vehicle, we used to call them breakdown vehicle, as if it's the hearse van, doing the last ride. So we changed the name. We now call them the power restorer. Well, at least there should be some hope there. He's going to restore your power. So that power restorer used to go there, and then the maintenance shifted to the new phase, what we call preventive. Now, he was painting every city the same color. He would maintain all of them whether they need it or they don't need it. So you are incurring cost. So now we have moved to the third phase thanks to this device. We call it predictive maintenance. Only if it requires you maintain. So you save on your vendor cost. So it's good for the utility, it's good for the consumers, and your response times goes up. You have all the records at your disposal. All this would not have been possible if the electronic and the electric sector would not have collaborated. So this product is working well. We have done it on 20 substations, and we are looking for some kind of a fund. We want to showcase it and put it across all the 2,250 substations. Our target is within a year, and then we think, and it's a very cost-effective solution. It is at Indian cost. at a NASA technology. That's how our guys put it. So that's the kind of, an out-of-box thought which can do. I already told you that it helps in condition monitoring, it helps to constantly give you the meter data, it helps to control the intrusions, it has automatic notification and escalation process. These are the gains for the utility and consumer. Simulator. Yeah. So I'll find it in 2 minutes. Okay. So simulator. The simulator, similarly we have worked. We have captured the entire activities of the distribution side into some 10 modules, and all of them are IT and electronic enabled, and those we impart training and use them for simulator. Maybe next time I get a chance, I'll elaborate a little bit more on this product. And this is also being patented as Drona. I don't know why they named it Drona. We certainly not asked the anguta of each of the trainer. So these are the 10 modules it does. So it works for all the 10 modules. I'll leave a copy of the presentation. Anybody who would like to see any of this product, they are welcome to our office. We can showcase all of them and show it to you. We are in Delhi. So there is this need for integration, there is this need for research and development, there is this need to look at this entire sector afresh for this sector to take off. Just one last thought. We have these brainstorming sessions, and our guys, they keep asking questions. So the latest question which is doing our round in our company is, why should there be a meter at the consumer's premise, for this business? They ask me, like, there is no meter for a telephone or a mobile. Why should there be a meter for an electricity business? And then you leave those meter, which is a cash box, at the consumer's premise, and then you expect them, then you tell them, look, he's tampering with your meter. Who is that for? So you got to think something out of the box, and we are coming up with a solution for it. And very soon, this is going to be a revolutionizing solution. We are in the process of doing a pilot test. If you go to a telephone line, can you push your jack in somebody else's port and speak? You don't do it. So why should anybody else tap electricity from your port and get electricity there? Do you have a problem with any of the telephone bills? You trust them. The meters are remote. Do they give you a flip-flop between prepaid and postpaid? Are they able to disconnect it remotely and connect it remotely? So if they give you certain service and you have contracted for that service, if you want anything more than that, you have to approach them. Suppose you have asked for a function load of 5 kilowatt, and then you draw 15 kilowatt and burn up the transformer or the line. Why do you allow it in the first place? There should be something to trip your supply and then tell you, look, you're contracted for 5, and if you want 15, it's time that you call up the utility and enhance your load. So I think there is a need for a lot of work on these areas. So with this little submission, I thank the organizers and everyone for bearing with me. Thank you very much.
Thank you, Mr. Narayanan. That's a wonderful presentation, and I think they have demonstrated how somebody who's not into manufacturing is actually showing the way into how you can manufacture products. So, you have a customer who's ready to buy all this innovative stuff. So I encourage all of you to approach me. Thank you. So I would now like to invite Mr. Narayanan during the presentation talked quite a lot about renewables and solar energy. So I'd like to invite Mr. Srivastava, who's Director, National Solar Mission, Ministry of New and Renewable Energy, to talk about the policies and the things they're doing in this department.
Good
afternoon, friends. As has already been told, I am from the Ministry of New and Renewable Energy. I would like to discuss with you the programs and policies of my ministry, but primarily focusing on the Jawaharlal Nehru National Solar Mission, which basically gives the manufacturers some direction towards electronic manufacturing. I would like to first draw your attention towards what is the power sector scenario, which has briefly been discussed earlier. The total power generation capacity put together, all sectors put together, that is roughly some 200 gigawatt. Thermal obviously is the major share, that is 67%. The renewables, that is so far as the capacity, installed capacity percentage is concerned, it is 12%. Now, if we come to the renewable power capacity, the total power capacity installed so far as renewable is concerned, that is 25 gigawatt. And out of that, the major share is by the wind, which is roughly 18,000 megawatt. The solar, which was at a very low position a short while, a few years back, has now become 1,176 megawatt. What are the challenges India is facing? We have the greatest challenge that in the next 12 years, the electricity requirement that is growing very fast to the tune of 2.5 times. The shortage is enormous, that is to the tune of 25 to 35 gigawatt. There is a problem of issues relating to climate change. We still have some 400 million people who are devoid of access to electricity. And of course, our import, oil imports, that is ever increasing. This is the reason why we are now resorting to renewable energy. As we know that renewable energy is such an energy which is getting replaced or regenerated at the rate at which it is being consumed. And the greatest advantage of renewable energy is that we can go for decentralized and distributed installation, thereby meaning we can approach such places where the grid connectivity is not there, or where it is very difficult, it is not economically viable to have the lines laid, as our previous speaker has already pointed out. The other advantage of the renewable installation is that it has got a very low gestation period. That can be installed a power plant, a photovoltaic power plant, standalone of a megawatt size can be installed with all the clearances, etc., within a period of 12 to 13 months. These are the various sectors wherein the renewable energy is required, can be utilized. We have got the grid side, the off-grid side. We also require for the industrial sector, the residential sector, as was being discussed, for solar water heating purposes. Now, this particular slide gives an overview of how the renewable energy has progressed. We had only 3.5 gigawatt by 2002. It has climbed to 10.2 gigawatt by 2007. 2012, it has reached 25 gigawatt. And by 2017, we have a plan of reaching 55 gigawatt. This chart also gives a view how the things have progressed. Now, if you see the aim of this ministry, by 2017, we want to reach a level of 55,000 megawatt, wherein the solar component would become 10,000 megawatt. I will come to the solar component separately, and by 2022, the projection is that we'll be reaching 81,000 megawatt, and the solar, that is 20,000 megawatt. If you see the electricity mix at present, if you the total capacity of the renewable, that is roughly some 25,000, and the billion units that is being produced, that is 51. The share is only 4.18%. The share is likely to increase by 2017 to 5.26%, and the electricity mix share by 2022 to 6.51%. To achieve this, Government of India initiated some 8 missions, wherein Jawaharlal Nehru National Solar Mission is one of them, under National Action Plan on Climate Change. As all of you know, it was launched in January 2010, and it is a major global initiative. The mission primarily aims at achieving grid parity by 2022. What is the roadmap of this mission? We have 3 major sectors. The first is the grid solar power. The target for the period 2010 and 13, that was 1100 megawatt. This is for the grid connected ones. It increases to 10,000 megawatt by during the 12th plan, that is 2013-17, and 17-22 to 20,000 megawatt. This is cumulative figure. The off-grid side also, lot of impetus has been given, because this is the sector where the real growth is going to take place, and lot of importance in the off-grid side has been given during the second phase, that is during the 12th plan period. And if you see that during the first phase, it was only 200 megawatt that was planned, which has been hiked to 1,000 megawatts, and finally we are required to achieve 2,000 megawatt by the end of phase 3. The solar water heating sector also, if you see, the plan is given 7 million square meters during the phase 1, 15 billion square meters during phase 2, and 20 million square meters during the phase 3. So is the case with the solar lighting system. We have some policy and regulatory support. There are issues relating to RPO, that is Solar Renewable Purchase Obligation, and REC, supporting grid connected projects, financial support for off-grid, support R&D in India, encouraging manufacturing, and HR development. I will now come to the phase 1 of the grid connected target which we had. As I told you, during phase 1 we had the total target of 1100 megawatts. That 1100 megawatt was broken into 2 batches, that is batch 1 and batch 2. In the batch 1, we further had various programs and schemes. The first scheme which was implemented by NVVN, that is through the bundling of unallocated power with the solar power. As you know that the unallocated thermal power that is cheap, whereas the solar power that is costly. The CERC tariff at the time when this scheme was launched, that was 17 rupees 91 paise. And obviously nobody would like to purchase such a costly power. So what we did is, we bundled the cheap power with the costly power, that is 1 megawatt of the unallocated thermal power with the costly solar power. And that was the main scheme so far as the first scheme that was launched, and that was administered by NVVN. It was the total projects allocated, that was 30, and that was totaling 150 megawatt. Few of the projects did not meet the deadline, and because of which they could not be commissioned within the scheduled time. 130 megawatt got commissioned, and if you see the tariff, the minimum tariff, bidded tariff, that came to 10.95. The highest was 12.76, average is 12.16. The reduction in tariff was to the tune of 32%, and this was first time, because of the reverse bidding process, the tariff could come to such low level, whereas the CERC tariff was 17 rupees 91 paise. There were certain projects which were already, before launching of the Jawaharlal Nehru National Solar Mission, they were coming up in various states. We gave an option to these projects to come to JNNSM, and they migrated to this scheme. Here also, we had the photovoltaic and the solar thermal both. Here 48 megawatt has got commissioned. Only 2.5 megawatt has got commissioned the solar thermal. There were certain issues because of which they could not meet the deadline. Then we had the third scheme, which is the RPSSGP scheme, wherein we wanted very small projects of 1 to 2 megawatt size to come up in almost all the states of India, so as to basically popularize the solar projects. And under that, 98 megawatt that was allocated, and 88 megawatt has got commissioned. So far as the solar thermal projects, again with the NVVN, 470 megawatt has been allocated, and the likely date of commissioning of these projects is by May 2013. Here also, there was great reduction in the tariff. These projects are under various stage of erection and commissioning. Then we had the second batch of JNNSM, wherein 350 megawatt was tendered out. The minimum bid that came down to 7.49, maximum was 9.44. Here also the commissioning is by February, the scheduled commissioning is by February 2013. But in the month of December itself, some 20 megawatt has got commissioned. A major chunk is likely to be commissioned by January, and balance, it is presumed that means maximum by 340 megawatt or so would get commissioned by the D date. Now, if we see what is the state-wise capacity, Gujarat has really moved ahead. They have installed 824 megawatt. Rajasthan is the number 2 in this category. They have installed 200 megawatt. The total installed in general, putting together all the states, that comes to 1,176 megawatt. These are the state initiatives. Gujarat has announced roughly some 1000 megawatt. Out of that, they have already commissioned, as I told, 824. Other states have also announced their program. Rajasthan with 200 megawatt. Other states like Tamil Nadu and Andhra Pradesh they have also of late announced. Tamil Nadu and Andhra Pradesh, they have gone for tendering of 1000 megawatt each. So far as the off-grid side is concerned, for the phase 1, which was from 2010 to 13, the total target was 200 megawatt. Out of those 200 megawatt, we have already allocated or sanctioned roughly 175 megawatt, and it is expected that this will be completed in the balance months to come. The solar thermal side, the total target was 7 million square meters, out of which 6.17 million square meters have been collected area has been allocated. Most of us would be knowing about this, that the scheme of the off-grid SPV system, we have certain subsidies which are being provided. To the special category states, we provide 90% of the total project cost, limited to 243 rupees per watt. And for the balance states, that is 30% of the project cost, not exceeding 81 rupees per watt. Now, JNNSM has got major role, or this is also one of the objectives so far as manufacturing is concerned. And this is one of the target to have a total installed capacity of 4 to 5 gigawatt. At present, I will go to the subsequent slides wherein we have listed out who all manufacturers are and what are their manufacturing capacity. But MNRE basically encourages the manufacturers to set up projects wherein MNRE gives lot of custom duty and excise duty exemptions. It also supports manufacturers to set up their projects with some capital subsidy from the National Clean Energy Fund. The Department of Electronics and Information Technology also encourages manufacturers to set up projects under modified SIPS program. What MNRE has also done is a domestic content requirement that was put in place during phase 1 of the JNNSM. The domestic content requirement was such wherein in the batch 1 projects we told that all the solar power developers who want to install solar power projects with crystalline silicon technology, there are two major technologies, that is the crystalline silicon and the thin film technology. So whosoever goes for crystalline silicon technology will have to have all the modules of indigenous source. Thin film and other technologies were allowed. The idea at that time was that we were not having much of thin film manufacturers. Very little thin film manufacturer was there, that capacity was available. And because of which, it was the domestic content requirement was put only so far as the crystalline silicon technology is concerned. During batch 2, the domestic content was further the ambit was increased, and the cells and modules both were covered under the domestic content requirement, again with the crystalline silicon technology. The same was true for the off-grid side. So far as the solar thermal is concerned, it was 30% of the total project cost to be of indigenous nature. the manufacturing capacity in India of solar cells and modules. We have Indo Solar as the largest producer of cells. It has got the installed capacity of 360 megawatts. Then we have got Mosovere, which has got roughly 250 megawatts. The module manufacturing side, we have got several manufacturers. Mosovere, MV Solar, XL Energy, and there are several other manufacturers. The total module manufacturing capacity, that is roughly 2000 megawatts, and the cells is roughly 1000 megawatts. If you see the graph of how the cost has fallen down, you will find that in 1985, in 1985 the cost was roughly $7 per watt, and now I will show you the second slide, wherein it has come down to roughly $0.6 per watt. This slide shows the general scenario so far as the global cost is concerned. The China has put several manufacturing units with large manufacturing base, and the prices have come down to even 0.35, and because of which most of you must be knowing that several countries have imposed anti-dumping duty. India is also doing that. Some investigation is on. The technology mix, if we see, 87% is crystalline and only 13% is various varieties of the thin film. Installation wise also, if we see, it is roughly 86% crystalline and only balance is thin film. But if we see the Indian situation, the Indian situation shows a different pattern altogether. In the first phase where the RPSSGP program was there, the crystalline was 57%. Batch 1 NVVN administered projects, it came down to 50%, and now it has come down to 29%. The lesson learned by MNRE during this period has been that the domestic content requirement which we have put only for the crystalline silicon technology, not on the thin film. The SPDs have gone ahead with the thin film technology, wherein that has been assisted by certain banks, primarily the Exim banks, which has given very soft loan at very low interest rate, and the result is that various thin film manufacturers have supplied the modules and cells, and that has been basically installed. The ground monitoring, the solar resource assessment stations, we have installed 51 ground monitoring stations. This is very, very essential because SPD should know where exactly what is the DNI, then only he will be in a better position to design the system. The bankers also get a lot of comfort if this data is available. Then we come down to the second phase. The second phase, as I have already told, the grid connected, it is 10 gigawatt. The off-grid cumulative figure is 1000 gigawatt, and the solar collected area, that is 15 million square meters. How do we want to do that? This 10,000 megawatt we have basically split into two parts. 4,000 megawatt we want to do with the under the central schemes, and 6,000 megawatt under state initiatives to meet the solar RPOs. These are the options, because this phase 2 has to come after March 2013. So these are the various options which we have thought of. We have thought of to continue with the bundling scheme, wherein for the bundling scheme, we require unallocated power from the Ministry of Power. So we have thought of going ahead with a scheme of 500 megawatt. That will be a purely photovoltaic. As I already mentioned, that this scheme has been very, very successful so far as phase 1 is concerned. The bankers were very comfortable because NBBN was the single off-taker, and the average price had come down to approximately 5 rupees. Then we have the second option wherein we want to go with the viability gap funding, because still the cost of putting up of a solar plant is high. So we want the bidders to bid for VGF per megawatt. The advantages are that it is very simple procedure, and if we give some capital subsidy or capital subsidy upfront, this will basically the cost of financing would be lower. However, the disadvantage is that upfront payment of VGF may not ensure performance of the project. The proposal is that 25% of the capital subsidy would be given at the time when the 50% of the major equipment is placed at site, 50% on successful commissioning of the full capacity of the plant, and 25% after 1 year of meeting all operational requirements. Under this VGF, out of the 4,000, we want to go ahead with 2,250 megawatt. Maybe another 2 minutes. Then we want to go ahead with some solar parks. This is really very, very encouraging, because we have found in the phase 1 that the projects were coming very in a distributed pattern, where the evacuation was a major problem, and all the SPDs really faced problems relating to evacuation. So we want to develop solar parks with the assistance of the state governments, wherein all the facilities, infrastructural facility will be created, and the solar developers would be asked to bid in that particular solar park. Certain support we have thought of giving while developing the solar parks. The target for the off-grid, as I told, that is 800 megawatt. The various schemes for the off-grid is energy access, means basically providing energy to the remote locations. Telecom towers, we all know that the telecom towers, they consume a lot of energy, and this energy they consume out of diesel DG sets. So here also we have thought of, the target is around 25,000 solar integrated telecom towers. Water pumping, as was discussed earlier, here also we have a target of 25,000 solar pumps during phase 2. Off-grid lighting, that is street lights, home lightings, that is 10 lakh off-grid lightings. Solar water heating systems, that is a major thrust area for us. And then the air conditioning and refrigeration, that is the heating and cooling, which was discussed earlier. These are the options which we are considering for the phase 2 for domestic content. One option could be that for all PV projects, cells and modules produced in India shall be used. The second option is price preference for domestic manufactured cells. The third option, which we are thinking, may be percentage of domestic content in cost terms. The fourth option is percentage of cells manufactured in India, or otherwise some batches with 100% domestic content requirement. And for this thermal technologies, material equivalent to 50% of supply cost. These are the options which are being deliberated upon. It will be finalized very shortly. These are the various issues which are being dealt. That is the enforcement of RPOs, strengthening of transmission network for renewables, unallocated power, then the funds from the National Clean Energy, import duty concession for inputs to the manufacturers, incentives for manufacturing under MSIPs, and funding of solar projects by the banks. These are some of the projects which have already been commissioned. This is all about solar heating. These are all solar lightings, home lightings, lanterns. This is solar pump set and blinkers. This is all about my presentation. My presentation would be available here. Anybody who wants can have it or may contact me straight away. Thank you.
Thank you, Mr. Srivastava, for giving an overview of what MNRE has done and what are you aiming to do. So I think people will be encouraged by some of the schemes that you have for hardware manufacturing under your under MNRE. So please approach Mr. Srivastava if any of you are interested to know more about these schemes and incentives that are available. And I'd like to invite our last speaker for this session, Mr. Mukundan. He's AGM Product Management and Exports with Tata Power Solar. Just while we're getting ready, so there is a quick announcement. We'll be having 2 more sessions after lunch. There is one session on IT manufacturing, which is in the auditorium, and the other session on medical electronics will be in this room. So please choose your sessions accordingly.
Hello everyone. My name is Mukundan. I have a middle name of Max. That came from my 15 years of life in the US. Actually, I am very passionate about solar. That's one of the reasons why I came back to India and hope to make a difference in the solar space in the country. Give you a first a brief overview of the Tata Group, which I'm sure most of you are familiar with, but maybe some of the details that I present here will be you may not be familiar with. And also we'll talk about what our business overview is, specifically focused on modules and our standard products that we bring to the table, and give a little bit of update on the Indian policy status from a manufacturer's perspective. So for the people that don't know, Tata is one of the largest and most trusted business group in the country. We are in 7 business sectors: materials, engineering, IT communication, energy, services, and consumer products. We're operating in over 80 countries. 58% of our revenue comes from outside of the country. So we have about 425,000 employees. That's a lot. Thanks to Ratan Tata, we crossed the 100 billion mark last year. So this is from Tata Power Solar, our group. We are committed to enabling solar everywhere and bringing the power of the sun to the people in the most efficient and cost-effective way possible. So just a brief history on Tata Power Solar. Has been around for over 2 decades. 23 years we've been part of a group, a joint venture between Tata Power and BP Solar. End of last year, we basically moved, BP basically moved on, and Tata Group basically acquired the full stake in the company. Now we're owned by Tata Power. And we're headquartered in Bangalore, which is known as India's Silicon Valley. We have several awards that we have won, including the FICCI Award, the Golden Peacock Award, and the National Award for Engineering Exports. So with this, thanks to BP, right, we have 20 years of partnership through which we have exported over 500 megawatts of modules globally. So being a part of a global conglomerate that has participated in the global market space is what this BP experience brings us. Some of the countries we have served include USA and Spain. With that experience, what comes to the company is meeting stringent module requirements, meeting certification standards, and going beyond certification standards. Right. So now that the three values that we bring to the table is the dependability, lifetime value, and this peace of mind that there's a large, strong enterprise that's backing up these modules, which majority of the Chinese guys lack in the world. So just to give you a brief business overview, now as part of Tata Power Solar, we operate in 5 varying segments. One is of course the module segment, where we have 84 megawatts of cell manufacturing capacity and additional 96 megawatts upgradable. That we can do that very quickly within a few months. And we also have 125 megawatts of module manufacturing. All of these comes with high quality process that BP has enabled us. Obviously, we are willing to work with other manufacturers to transfer and our know-how of the quality of our product, so that India as a country becomes more of a quality-focused module manufacturing country. So second business group is the standard product segment, where we have operated on home lighting system, solar power packs, which I will talk about, the street lighting, and of course the solar water pumping. All of these business, we had the time and luxury to develop these products over the last 23 years. And some of these, like the home lighting system, has been around for 10 years. Proven product in the field in very, very difficult working conditions. So the third segment is of course the large project segment, where we do EPC, or engineering, procurement and construction. We do the installation, commissioning, metering and monitoring, as well as the operation and maintenance of large power plants. Some of it came under the MNRE JNNSM scheme, phase 1 and as well as phase 2. The fourth segment is of course the industrial solutions group, where we interact with various industries and commercial entities, where we provide end-to-end energy solutions through solar. Solar is an amazing field where distribution may not be required, right? So basically, you're producing the energy at the point of use, and this is where I think the IT industry is looking at it very seriously. Textile industries are looking at it seriously, where they have huge power crunches, where depending on diesel, for example, instead of grid, where grid is not available. And then the fifth segment is of course the solar thermal segment, where we have coverage pan-India. Product comes with superior warranty and quality. Let's talk a little bit about the modules. As I said, we bring in the ISO 9001 and 14001 certified, and that quality goes with every one of our products that we sell, including the modules. And we have a wide portfolio of products, all the way from 1 watt to 300 watts. So that's some of the products now. On the home lighting section, we have street lighting, solar pumps. Specialty products is one area where the picture that you see on the left bottom is a solar powered vaccine refrigerator used in remote areas for storing vaccine. So and then in addition to that, we have the power packs and several of the water heating products. So if you look at the large project segment, as I said, we've done about 60-70 megawatts over the last year. One of the largest large projects entity. Some examples are shown here: 3 megawatts in Mulshi near Pune, 1 megawatt NDPO project in Delhi, and 17 megawatts in Gujarat. As far as the IS or the Industrial Solutions Group, you can see a list of projects. Rooftops that are covered with solar, idle space that's producing energy for you. So that's an example for the solar water heater solution. We have both for corrosive and non-corrosive water conditions. I'm rushing through because I want to cover some of the main items. We have, as I said, the product proposition is high energy yield, warranty, durability, and reliability. So the key areas that we focus on is bringing in the high energy yield, because we use something known as the anti-reflective coated glass, which keeps in instead of 96%, 98% of the input energy. Our warranties are industry standard warranties. We're looking to expand beyond that because our testing results have shown a much better performance. So those are all some of these certifications, thanks to all of the years of work that we've done. And standard warranties apply for all of our products, module series. So that's on the larger framework for modules, as well as we have smaller area products that are modules. So now coming to the standard products. See, if you look at the access to electricity, India is probably the largest country where the largest percentage of the population is living with no electricity. 403 million people in India are living without electricity. This is the census results, out of which, if you look at it, the problem is more critical in the northeast, UP, Bihar area. About 60% of the households still reside on using kerosene, which is not, number one, not healthy, and kerosene has been given so much subsidy within the country. It's almost unbelievable that such subsidy could be diverted to solar. Then it's a lot more healthier standard of living that we can produce with solar. So as Mr. Ramesh pointed out, lighting in the area where grid electricity is already available may not be a great source or use for solar, but in those unelectrified villages where 403 million people are living, lighting is a key need. It brings them higher standard of living, more income that they can generate, lower health hazard, where we're generating women empowerment, lower environmental pollution issues because of kerosene usage, which basically ensures that we have inclusive growth as well as the charters of the Bharat Nirman. Some examples where we've done this, we are probably one of the largest installed base of home lighting systems. About 60,000 unelectrified homes have been lighted by us each year, thanks to the NABARD subsidy program, working in parallel with MNRE, of course. So if you look at these, what we bring to the table here's a Moradabad UP store that operates at the night, where he could not operate, and people come there and buy his stuff. Women empowerment, all of this can be done through solar. So these are our standard list of products. You can look at them at our website, so I'm not going to spend a lot of time on that. So street lighting. So once you've lit the homes, the streets need to be lit as well. And many areas where there's no electricity, solar becomes an ideal choice for that. And what we bring to the table is affordable pricing points, where we look at the levelized cost of electricity, not just upfront capex. That's an example street lighting solution. Now power packs, right? So power packs are, it's very simple. It's got a module, it's got some cables, a charge controller, and a battery. That's what it is. So you can store the electricity coming out of the solar, and from the battery you can connect to whatever applications you can. They come from less than 210 watt, which is of course subsidized by NABARD. Now we have products that go up to 6 kilowatts, which can power a home, for example. Right. So and the price points are coming from the NABARD scheme, about 150 rupee per month. The entire home is powered by solar, which is very good for the rural setting. So some of the areas where we have operated in, here's an area in Ladakh where the only mode of transport for the modules was on top of a yak. So we have operated in sort of difficult terrains to enable solar everywhere. Here's the example product. Yeah, sure. So we talked about pumping as well. So I want to ensure that we talk about pumping here. I really commend the effort by Ramesh and his team for enabling pumping type of solution in Delhi. Here's a product that we've done, deployed in Haryana and Kargil. We have both DC as well as AC pumping solutions. To me, pumping is an ideal candidate for solar. You need the water when the sun is there because it's hot, and that's when we can produce the energy. It's just a perfect match for solar as a product. Some more specifications on the pumping side. So I'll highlight the presentation with this policy status and charter. I think this is where I think the industry needs to work really close with the government. Let's see what has happened so far in phase 1 as far as domestic content requirement. So you saw in the Yamuna presentation earlier that about 70% of the projects was done with imported thin film in phase 1. So what the thin film folks did cleverly is club with attractive financing options like Exim Bank financing, which is really lured the developers away from the local crystalline manufacturers. And also state programs, with a drive to increase faster adoptions were devoid of any kind of local content requirement. So in the end, what happened was, the domestic manufacturers were hit with like a double-edged sword. One is the industry, the Indian supply base was kind of relatively young. For example, I could not go to a local EVA manufacturer to buy EVA from them to integrate into my module. I had to buy expensive components from abroad to meet the high quality and the reliability requirements. One, because of that, our cost was somewhat higher. Then in addition to that, we also had the high import taxes, almost 17%, 16.84% on all the components that we import to sell into the local market. So that way, it was not competitive, let's face it, right? The overcapacity in China also led to dumping of the crystalline modules in the rest of the world. There again, we proved to be less competitive in the rest of the world. This resulted in underutilized factories, although we show that we have 1.1 gigawatts of capacity locally. Majority of that factory right now is underutilized. That's the fact. And suddenly the noble goal of 4 to 5 gigawatts of Indian manufacturing capacity by 2020 seems far away. So now let's look at phase 2 policy. Right? There is a renewed focus on DCR, which is very good. I think we need to improve on the definitiveness and the clarity of which of those 5 schemes will be enabled. And we need to work hand in hand with the rulings of the anti-dumping investigations that are going on against imports from China, US, Malaysia, and Taiwan. And we believe that DCR should be technology agnostic, which I saw in the Yamuna presentation, which I'm enthused about, to include crystalline thin film as well as CPV. Here's a proposal from our side. Need to couple financing as well as DCR. Our suggestion would be, even when the financing is coming internationally, make 50% of the modules to be domestically sourced. Then have a minimum of 75% for projects funded by either VGF or budgetary support or National Clean Energy Fund. So in respect to the PV projects made in a given year, obviously wafers still as an important component. We want to make sure that the manufacturers are following the proper protocol and ensure that we can import the solar wafers of the same technology at the same time. And we can prove that through bill of lading, so that there's no concerns of cheating or anything going on in the manufacturing. So I want to also highlight some of the work that the modified SIPS program that Mr. Srivastava mentioned. So we are encouraged by that. This includes solar manufacturing options. So any kind of upgradation to the factory or any new R&D work that happens that results in the manufacturing of newer types of solar panels which are higher efficiency comes with a certain subsidy, which is a very good thing. This kind of subsidy has been enjoyed by the Chinese manufacturers for a long time. Right? It's high time that India starts doing that. The scheme is basically a large project has been floated with the objective to address issues of very poor manufacturing base in India. I mean, you saw the capacity. Even though the capacity seems reasonable, it's still underutilized. We need to get that. So the second portion of the MIPS is work done where we talk about the market access scheme done by DIT. I mean, it's amazing that the Department of IT and Communication has got through this, and this gave us an idea where we can't be just dependent on MNRE or JNSM. Maybe we need to look at other departments as well, because if you look at distribution options where you're able to generate energy at the source where you're going to use, right? So you could look at solar industry is really poised to gearing up to provide innovative solutions for promoting inclusive growth. First, in the rural segment, if you look at inclusive growth, we can leverage CSR initiatives of public sector units, possibly with the Ministry of Company Affairs, as well as the Ministry of Rural Development could create grants for self-help groups, schools, panchayats, banking, post office, etc. that could use some of these either solar pumping or solar lighting options. Now we come to the kill diesel program is what I call it. Solar-based products and services for user industries will effectively replace rampant use of diesel and kerosene. This is clearly needed in an area where, if you look at millions of people die because of kerosene, either bad air pollution or fires. So this is an area where we think that the mandate the municipal bodies and utilities to make solar alternatives to provide extra energy needs for industry clusters, farmhouses, health resorts, mandis and social functions, etc. And then we need to also strictly verify the norms of the release of subsidies for diesel and kerosene. Where in the food chain is the subsidy, really? I mean, does it really reach the end guy or not? Then, if you look at the solar solutions for real estate, hospitality, infrastructure, and communication, water heating solution, common lighting area could all be done through solar. Solarization of telecom tower, billboards, data and usage like railway booking booths, ATMs, rural IT, broadband connectivity, government buildings. So many areas where solar can contribute. So here we put a call for action to the Ministry of Finance, Telecommunication and IT, Urban Development, Rural Development, Roads and Highways, social justice, women empowerment, company affairs to create an enabling environment for solar. And we have the highest potential for in terms of insulation for solar, one of the highest. If a country like Germany with very little solar, can do gigawatts and gigawatts of solar power plants, we have immense potential to deliver a solar nation. That's my presentation. Thank you.
Thanks, Mukundan. I think we have had some very interesting talks and presentations, but we are running a bit behind schedule, so that's why I won't open for question and answer. So the panelists will be around, and please feel free to put the questions to them, because I don't want to keep everybody from lunch, and we have to start the next session at 1:45. I apologize, we're running late, but thank you for your understanding. My thanks to all the panelists for being here, for sharing their thoughts and views. It's been really very interesting. Thank you so much.